Okay, for these three, it looks like, limit questions or asymptotes, but it's really more about understanding your algebra and understanding what the graphs look like. So here we go. Okay, so remember, for the limit to exist, the left-hand height has to equal the right-hand height, but there can be a hole there for the limit to exist, okay? And the limit would be the height of that hole. There could also be a solid point there. If there's a solid point there, then you would also say that it's continuous, okay? The formal definition of a limit. For the limit to exist, let's say this hole that we had here a second ago, I'll put the hole back in there. Okay, let's go back to the formalities. Let's say the hole had coordinates 1, 2, okay? For the limit to exist, the limit as x approaches 1 from the left has to equal, or this height has to equal the limit as x approaches 1 from the right. The limit as x approaches 1 from the right. If that is true, then even if there's a hole there, the limit exists. Okay? Now let's change that. That means limit exists, and that limit, the value of that limit would be the height of the hole. And by the way, I made that number up. It has nothing to do with the problem. All right, now let's do, does the function exist? Okay, that would mean that there's a solid point there. If those two values are the same, the limit and the function, then we would say it's continuous. So let me go over it being continuous. For this to be continuous, these two things would have to be true, and a solid point would have to exist. And it can't be like down here, okay? The solid point has to actually fill that hole that we drew, okay? Which means we'd have to add one more thing for this to be continuous. The limit from the left has to equal the limit from the right, but that also has to equal the value of the function. All three of them would have to be the same, which makes sense graphically, but it's harder algebraically. So it's important to understand graphically what you're looking for so that you can answer this. So what is happening in this problem? Taking the top piece, if we factor that, it's x plus 2, x minus 2 over x minus 2. Since the x minus 2's cancel, hopefully you remember that that means there's a hole when x is 2. Okay, so graphically, this is literally the line, the graph of the line y equals x plus 2, but there's a hole in it when x is 2. If I wanted to graph it, it's y-intercept of 2, slope of 1, up 1 over 1. It would be this line, but at 2, there's a hole in the graph. Over 2 up to this point, that point doesn't really exist. There's a hole right there, okay, at 2. So the question here is, does this stray point, that stray point has coordinates 2, 3. Is that a stray point that is somewhere like up here and it doesn't fill the hole? Or is that a stray point down here, it doesn't fill the hole? Or does it fill the hole right here? Okay, well, to find the height of that hole, you plug in the 2 that we found where the hole exists. You plug that into the simplified equation. If I plug a 2 into the simplified equation, you get 4. So the hole has coordinates 2, 4, and this point has coordinates 2, 3, and therefore, this stray point is not filling that hole. Now, to put that in calculus speak, the limit as x approaches 2 is the height of that hole. So we take just this guy right here, we cancel. What is the limit as x approaches 2 of this guy after we factor it and cancel? Well, cancel and plug in the freaking 2. You get 4. Okay, so yeah, it exists and its value is 4. Okay, this would be 4. The value of the limit if they asked for it. Part 2, g of 2 exists. Well, yeah, that's this guy right here. G of 2 is freaking 3. Okay? Part 3, is it continuous? Well, if those two things were the same, it would be continuous. Since those two values aren't the same, the answer to that question is nope. So, final answer, we want 1 and 2 only. Option C. All right, so on to the next one. Number 28, it's really kind of the same thing. Let me see what we got. And I really think this is sort of the same thing. I'm going to go ahead and factor an x out of the numerator, and you're left with x minus 1. Take an x out, or sorry, I can't do anything with the denominator, but these guys cancel. So there's a hole in this function. Just like the last one, there's a hole when x is 1. What is the height of that hole? Well, it's the limit as x approaches 1, or just plug in the 1 to the simplified equation. So the height of the hole is also at 1. All right, so there's a hole at 1. So in order for this to be continuous, then we have to fill the hole. So f of 1 has to be 1. Okay, I don't know if that makes sense, as much sense to you as it does to me, but you're basically making sure that you fill in the hole. And it has a hole at 1, 1. So if you have a line, basically this is really the line y equals x. It's this line. But the fact that this was here means that at 1, if you go up to your graph, that point is really not there. There's a hole right there at, well, what are the coordinates of that hole right there? That's not a hole. One moment, please. What are the coordinates of that hole right there? If you plug in the 1 to your simplified equation, which was just an x, you get 1. So the hole is at 1, 1. So to make it continuous, fill the hole, which means f of 1 has to also be 1. Hope that makes sense. It seems too easy. Okay, 29 is also about graphs, but not really the same concept as the last two. Here we go. Okay, this can be done with Algebra 2 concepts, and it can also be done with limits. All right, first of all, vertical asymptotes are going to occur only when the denominator equals 0. And by the way, just an overall review one more time. Let's say you had a function. Let's say, and it's not this function, but let's say we had, I don't know, that's a 2. Let me try again. X minus 2. And then we've got a x minus 2 here, and maybe an x plus 3, making it up as I go along, okay? Overall, in general, you will have some sort of problem, a discontinuity, anytime the denominator is 0. So you've got an issue when x equals 2, and you've got an issue when x is negative 3. What are the issues? If it cancels, it's a hole. You currently have a hole at 2. And to find the y coordinate, you'd have to plug the 2 into the simplified expression or equation. Okay, so there's a hole at 2. If it doesn't cancel and it's still there, it's a stubborn pain in your asymptote. This is a vertical asymptote. It doesn't go away. Okay, if it cancels, you have a hole at 2. If it's still there, it's a stubborn pain in your asymptote. That is a vertical asymptote. Okay, so that's how you kind of handle the vertical asymptote part. All right, so let's go back to that part, and then we'll worry about the horizontal asymptotes next. Okay, so just looking at the denominator, when will this equal 0, and does it cancel? Well, it doesn't cancel with anything in the numerator. We could factor it if you wanted to. It's 2 plus x, 2 minus x, but neither of those are going to cancel with this. So basically, you have a vertical asymptote at both x equals negative 2 and at x equals 2. You could have also moved the x squared to the other side. Either way, there's a vertical asymptote when x equals plus or minus 2. So we definitely have 2 vertical asymptotes. Which of these say 2 vertical asymptotes? Well, it can't be B, could be C. Can't be D, could be E. A doesn't even mention it, so I'm thinking it's not that. But right now we have 2 vertical asymptotes. 2 vertical asymptotes. Okay? Now we're moving on to horizontal asymptotes. The horizontal asymptotes, since this is just a polynomial over another polynomial, you can go back to your old Algebra 2 rules where you compare the degrees. That's one option. Since the degrees in the numerator and the denominator are the same, then you have a horizontal asymptote at the coefficients, 2 over negative 1. So you have a horizontal asymptote at 2 over negative 1, or at negative 2. But in short, you have one horizontal asymptote. So that would tell us that the answer has to be E. Okay, but I don't feel like I'm doing a good enough job explaining horizontal asymptotes if I leave it like that, because this one was actually too easy for like the AP exam. This is kind of a kind of a weak problem. So let's look at the real formal way you're supposed to deal with horizontal asymptotes, okay, if it were harder than this. Horizontal asymptotes technically would be what is the limit when x approaches positive infinity, finding that answer, and what is the limit when x approaches negative infinity. I at least want to mention it because it's causing me pain not to mention it, okay? Why? Why do you have to do two problems? Horizontal asymptotes means what's the limit at infinity and negative infinity. It wasn't necessary for this one, but I'll show you why here in a second. Let me clean up this screen. The reason you're supposed to check both the left and this is the left and the right, is because a graph could go like this. You've seen this before many times, okay? Where the limit on the right side, this would be the limit on the right side. The height you're approaching from the right could be different from the height you're approaching from the left. So you're supposed to check both limits. And the way you would check the limits would be to find these two limits. So you need to know horizontal asymptotes really mean limit as x approaches infinity, far right, and limit as x approaches negative infinity, far left. And remember, limit means height. Okay, so let me do this problem formally. Okay, limit as x approaches infinity. At infinity, infinity is so big that really this adding 4 doesn't really matter. We mathematically cheat and pop out the highest degree terms. We then simplify and you get -2. And well, dang it, that is the limit as x approaches infinity. Well, what is the limit as x approaches negative infinity? We cheat because infinity is so big that 4 doesn't matter. You get the same dang thing. When I simplify, I don't even have anything to plug in. It's still just -2. So there's only one horizontal asymptote. I may have made it worse by trying to explain it that way. You could also use L'Hopital's rule. The easiest thing to do is just know your algebra 2 rules. Ask me more about that one in class if I messed that up.